we are going to solve numericals based on mirror formula. Okay. This is now today is our 6th lesson in series from the chapter light, and we've already discussed in the previous videos about terms associated with spherical mirrors, ray diagrams of concave mirror, ray diagrams of convex mirror, uses of mirrors, and the last video was on the sign conventions and the mirror formula. This is in continuation of that video. I want you to watch that video before you start watching this video, because it will help you to understand better. The numerical solving will become easier once you understand the concepts discussed in the last video. So let's start with the numericals, and we are going to take 3 to 4 numericals in this class today. And I hope after solving these questions you will be more confident in solving questions. You can try a variety of questions after that, but you will be confident about how to start solving the questions. Fine. So the first question that we've taken, I've already written it on the board, and the question says, a converging mirror forms a real image of height 4 cm of an object of height 1 cm placed 20 cm away from the mirror. Right? Calculate the image distance and the focal length. I have taken this question because a lot of things are given, a lot of concepts will come once we solve this question. And so first of all, what we are going to do is we are going to write down what all is given to us with the proper signs. And if you remember, in the last class we talked about sign conventions, and we already know this. And just to revise, I'm drawing this in front of you. We all know that whenever we measure distances parallel to principal axis, we start measuring from P as the origin. Distances measured left to right are positive, right to left are negative. Distances measured perpendicular to and above principal axis are positive, perpendicular to and below principal axis are negative. If you remember this diagram, you can remember the sign conventions. Okay. So first thing that is given to us is forms an image of height 4 cm. So height of image is given to us is 4 cm, and it's also given that the image is real. So this you have to take care. Now real images always form below the principal axis downwards. It is always inverted. We know that. Therefore HI will be minus 4 cm. Distances below the principal axis are written as negative. Second, what is given to you is object of height 1 cm. That is HO is 1 cm, and object is always taken above the principal axis, so it will be positive. Above the principal axis, positive. It is placed at 20 cm from the mirror. That means object distance is 20 cm. Object is always by convention placed in front of the mirror, to the left of the mirror. Always, we know this. For this, I'm telling you to watch the previous video for all this explanation. So object should be in front of the mirror, to the left of the mirror. So U will be therefore minus, because object is in front of the mirror. So we go right to left. U will be negative. What we have to find is image distance and focal length. So we have to find out V and focal length. This is to be found. This is very important. You have to write this before you start solving your question. So this is what is given to us. Now we are given HI, HO, U, and we have to find V and F, and the formulas that we are going to use. We know the formula for magnification we done in the last class is minus V by U is equal to HI by HO. Now this formula can help us to find out V. We know U, we know HO, we know HI. We can find V from here. So if I put the values, this will be minus V. U is minus 20. Be very careful with the sign, otherwise even if one sign goes wrong, the whole answer goes wrong. Height of image is minus 4 and height of object is 1. So this minus gets cancelled with this, and we get V is equal to minus 4 into 20, that is minus 80 centimeter. So V is minus 80. Now image is real, it's written here, and we are getting V as negative. So in a way we verified, yes, the image distance we are getting is negative, so it is real image. Real image is always formed in front of the mirror. So for a real image, V, the image distance should be negative. Okay, so we are getting that, and that is one way of verifying, yes, the answer is correct. What we have to find out else is, We have to find out focal length f, and we'll use the mirror formula. So we have 1 by f is 1 by v plus 1 by u. So f is to be found out. V is minus 80, u is minus 20. Be very careful with the sign. I'm again telling you. 80 LCM minus 1 minus 4, 1 by f. 1 by f is minus 5 by 80. F is minus 80 by 5, and that will be minus 16 centimeters. So our f comes out to be minus 16 centimeters. So f is minus 16 and v is minus 80. This is the answer. And we can verify our answer in a way. We are given that u is minus 20, f is coming out to 16. That means your object, this is between f and c. Isn't it? Object is between f and c. And the image should be beyond c. So it is, v is minus 80. What will be c? If f is 16, c will be at 32. And obviously v is minus 80. That means image is beyond c. So we have, that means we have verified our answer to some extent. So this is how we have to solve. The first step, very important. This is a very important step. If you write the sign correctly here, it's the probability of the question you doing the question right increases actually. But if any of the signs go wrong here, the question will obviously go wrong. If you do this step right, your question will be correct. Fine. This is question number 1. Let's proceed on to the next question. Fine. Okay. So next take another question, and the question is let's take question number 2. An object is placed at a distance of 16 centimeter from a mirror, and the image is formed 4 centimeter to the right of the mirror. Okay, so we have to understand the question correctly. The object is placed at a distance of 16 centimeter in front of the mirror, and the image is formed 4 centimeter to the right of the mirror, or we can say behind the mirror. Okay, find its focal length. Is the mirror converging or diverging? This is the question. Okay, so what we are given is, we are given an object is placed at a distance of 16 centimeter from a mirror, and the image is formed at 4 centimeter to the right of the mirror, or behind the mirror can be. So you are given u, object distance as 16 centimeter in front of the mirror. U is always taken negative. U is always, remember that u is always negative. It's always in front of the mirror. So u will be minus 16. Whatever mirror it is, u is negative. V will be behind the mirror, it's written. That means V will be plus 4 centimeter. Fine. Behind the mirror means it is the virtual image. So V will be plus 4 centimeters. Okay. We have to find F. So 1 by F is 1 by V plus 1 by U. And if we use 1 by F is equal to V, we'll write 4 minus 1 by 16. 16, 4 minus 1 is 1 by F. So 1 by F is 3 by 16. And F is therefore 16 by 3 centimeter. And it can be like 5.3 centimeter approximately. You can leave the answer in the simplest fraction also. So focal length is 16 by 3 or 5.3 centimeter approximately. And what mirror it is now? F positive means it is a focal length positive means it is a convex mirror. Convex mirror. Last class we talked about that a concave mirror has a real focus. The focus is in front of the mirror, so focal length is negative. Convex mirror has a virtual focus. Focus is behind the mirror, so it has a positive focal length. So positive focal length means convex mirror, and convex mirror we know is a diverging mirror. So we can say it's a convex mirror which is a diverging mirror. So sign will help you to find out which mirror it is. If the answer comes out in minus, it is concave. If the answer comes out in plus, it is a convex mirror. So sign of the focal length is important. Fine. So this is how. So we have taken U and V correctly, and that is how we are getting the answer correctly. If any of the sign here is wrong, the answer will be wrong. So this is question number 2. Let's move on now to the next question. Okay. Now the next question is, let's say we are saying now that we have a concave mirror of focal length 20 centimeter forms an image which is 1/4 the size of the object. Fine. This is what is given to us, and what you need to find out is find the position of object, and let's say of image also, and image, and also nature of image. Okay, let's say nature of image also. Now the question is, it is a concave mirror of focal length 20 centimeters. So we are obviously F is concave mirror means minus 20. Please always remember, concave mirror, the focal length is always negative, as the focus is in front of the mirror. Concave mirror, the focus is here, the pole is here. So as we go right to left, focal length should be negative, right? So focal length is minus 20. It forms an image which is 1/4 the size of the object. Size of image is 1/4 the size of the object. That means given to us is magnification. We know height of magnification is the ratio of height of image to height of object. The height of image is 1/4 the height of the object. That means magnification is 1/4. Now the question is whether it is plus 1/4 or minus 1/4. Now it is a concave mirror, and concave mirror M14 means the image is diminished, and in a concave mirror a diminished image is always real inverted. If you remember all 6 cases that we did for concave mirror, in a concave mirror real inverted diminished image is formed. We can never get virtual diminished image. So it is the diminished image, so it has to be a real inverted image because it is a concave mirror which is given to us. Okay, so if it is a real image, M will be minus 1/4. Again, in the last video we discussed in details about the value and the sign of M. So if it is a real image, M should be minus 1/4. Fine. So real inverted diminished image it means. So obviously nature of image we've already discussed. It is real inverted and diminished. Now this is given to us. Now we have to find out what you have to find is U object distance and V image distance. So this is all given to us. Now how to do it? We are given F, we are given M, we are not given any of these. So we know that M is equal to minus V by U. So we know minus 1/4, which is the value of M, is equal to minus V by U. Minus gets cancelled. So we get U is equal to 4V. If we put this in the mirror formula, 1 by F is 1 by V plus 1 by U. We put this in the mirror formula. F is 20 minus 1 by 20. 1 by V, and in place of U I am writing 4V. So we get, what we get is minus 1 by 20. We take the LCM, 4V, 4 plus 1. So it is minus 20. If I take the reciprocal is 4V by 5. Minus 20, this is simple mathematics, into 5 upon 4 is V. minus 25 centimeter is the value of V, that means, fine. And what will be the value of U? U is 4 into V. U is 4V. So U will be equal to 4 times this, that is minus 100 centimeters. 4 into 25, you know, is 100. So minus 100 centimeters are U. So F is minus 20. U is minus 100. That means object is beyond C. F is 20, C is at 40. U is 100, that means it is beyond C. Image, when the object is beyond C, if you remember, image should be between F and C. And image distance is 25, which is between F and C only. So somehow we have verified that this is correct. This is, we are getting the right answer. And the nature of the image also is asked, and it is, you know, real image. V is negative, inverted image. Obviously, if it is real, it has to be inverted. And it is diminished. Real inverted and the size is diminished. So this is how we take the value. So here this step was the most important step of this question. If you don't identify the sign of M correctly, rest is mainly mathematics. That will all go wrong and the answer will be incorrect. So this is the most important step in this question. Fine. Now I'm just modifying the question a little bit and see what changes will happen. Now if I make this as, instead of concave, I make this as a convex mirror and the question remains the same as it is. Now we have a convex mirror of focal length 20 centimeter, forms an image which is 1/4 the size of the object. Now how will the values which are given to us change? So this is the question 3rd that we are taking. Fine. Now we have changed the question to convex mirror only. So what are the changes? The changes are, now focal length will be, for a convex mirror, focal length will be plus 20. Convex mirror, this is a convex mirror. The focus is behind the mirror. This is P. So the focal length is from P to F. Left to right, positive. So it will be plus. Now a convex mirror is forming an image 1/4 the size of an image of the object. That in a convex mirror, the nature of image is always virtual, erect and diminished. You know this. In a convex mirror, virtual, erect and diminished image is formed. So because the image is virtual erect, the sign of M will be positive. M is positive for a virtual erect image and M is negative for a real inverted image. So M will be plus 1/4 here. Okay. So U and V you have to find out. So just by changing the question from concave to convex, I have just changed. The F has become, the sign of the F has changed and the sign of M has changed. So we'll now say M is minus V by U, we know. So we have 1/4 is equal to minus V by U. So U is equal to minus 4V. So we'll put this in the mirror formula and we'll 1/20 is equal to 1/V minus, in place of U I'm writing 4V minus 4V. So this is how the next step will be. We take the LCM. 1/20 is equal to 1/4V. 4V. So it will be 4 minus 1. So it will be 1/20. Simply mathematics is done. This is being done now. So V is coming out to be 15 centimeter. And U will be minus 4V. That is minus 4 into 50, that is minus 60 centimeter. So here the value, see the answer has all changed. And U is coming out to be negative. It should be, it is minus 60. V should come out to be positive because it is virtual erect image. So V is coming out to be positive. That shows the answer is correct. So what is the nature of image here? The nature of images also are, so it is virtual and erect. Because V is positive, the image is virtual erect. V negative means real inverted, V positive means virtual erect. Fine. So this is, you can just see, just by changing the mirror, all the values, the whole of the question remained the same. Just by changing the mirror, the whole set of solution has changed. The values have changed, the answers have changed. Let's move on to the next question, number 4. And now what I'm doing is, the question is now that we have a concave mirror of focal length 20 centimeter forms an image which is 3 times the size of the object. So this is what I've changed now. I have concave here and 3 times the size of the object. Focal length I've taken the same. Now let's see how to solve this question. Focal length of a concave mirror, which is a concave mirror, so minus 20. I'll not tell you again how, you already should know by now. M is 3 now. The image is 3 times the size of the object, that means magnification is 3. Now should it be plus 3 or should it be minus 3? It's a concave mirror and the image is magnified, which is given to us. And in a concave mirror, we all know we can get a real inverted magnified image as well as we can get a virtual erect magnified image. If you remember your ray diagrams, real inverted magnified image is formed when the object is between F and C, and virtual erect magnified image is formed when the object is between F and P. So we have to, that means say M can be plus 3 or M can also be minus 3. So we'll have to take both the cases. Okay, so what we'll do is, F is minus 20, M is plus 3. That means minus V by U is 3. That is V is minus 3U. This is a simple mathematical step I've done. So I've taken minus there, V is minus 3U. Now I'll put it there, 1 by F is 1 by V plus 1 by U minus 1 by 20, 1 by minus 3U plus 1 by U minus 1 by 20, LCM 3U minus 1 plus 3, fine. Minus 1 by 20 is equal to, this is simple mathematics, but you have to be very careful while doing these steps. A small mistake can go, the question can go all wrong. Now we cross multiply, 3U is equal to minus 40 and U is equal to minus 40 by 3 centimeter. Or we can also say 13.3 minus 13.3 centimeters. This is the value of U. What will be the value of V? V is minus 3U, minus 3 into this, and that will be 40 centimeter. Fine. That means when I've taken MS plus 3, that means I've taken MS plus 3 means I've taken virtual erect image. The image is virtual erect and magnified. Fine. And for that I am getting U minus 13.3. F is minus 20, U is minus 13.3 means object is between F and P. So the image, we know when the object is between F and P, image is virtual erect and magnified. And V is coming out to be plus 40. Plus means again virtual erect magnified image. So our answer is correct. This is one set of answers. So one set of answer is for M plus 3. The answer is U is minus 40. I am writing here so that I can rub that. Minus 40 by 3. And V is 40 centimeter. This is one answer. Let's do it for M minus 3 now. So I am rubbing this. So I am taking M as minus 3 now. Okay, so we are taking now M as minus 3. M minus 3 means we are taking real, inverted and magnified image we are considering. Okay, so that means we have minus V by U is equal to minus 3. That means V is equal to 3U in this case. And I'll put it in mirror formula. 1 by F is 1 by V plus 1 by U. And so 1 by F is minus 20. V is, as it, V can be taken as 3U plus U. 3U. 1 plus 3. 4 by 3U. And if you cross multiply, you get U is equal to minus 80 by 3 centimeters or minus 26.6 centimeters is u, and v will be equal to 3u. That means 3 into this. There's no minus sign here, please see. So it will be minus 80 centimeters. So f is minus 20, u is minus 26.6. That means object is between f and c. Because f is 20, c is at 40. That means object is between f and c. Image is beyond c. And it is real inverted magnified, and we know it is correct. And v is coming out to be negative, which is in confirmation with this, that the image is real inverted magnified. So v should be negative. Fine. So we have another set of answer. If we take m as minus 3, our u is coming out to be minus 80 by 3 centimeters, and v is coming out to be minus 80 centimeters. So in such a question, because it was a concave mirror and the image was given to be magnified, we have considered that the image is virtual as well as image is real, because in both the cases magnified image is possible. Virtual erect magnified as well as real inverted magnified. Fine. So we have solved few numericals today. Hope it will help you to understand how we to proceed in solving the numericals. So the most important thing is you write down with what all is given to you with a correct sign, and then use the formulas. That is the most important thing. If you get that right, writing what is given to you in the proper sign, the rest of the question is simple for you. Fine. So try practicing more questions, and that's all for reflection. So we have covered till reflection in today's video. Next class we are going to start with the leaf fraction. So that's all for the day. Have a nice day. Thank you.